Hello and welcome. Today we're going to talk about how to factor a trinomial completely by grouping. Previously, when I introduced factoring by grouping, we dealt with polynomials that had 4 terms. Today we're going to start off with that same concept, but we will lead into polynomials with only 3 terms at the end. So first we're going to recall how to factor each polynomial by identifying and factoring out the greatest common factor. For this first polynomial, notice my leading coefficient is negative, so I do need to make sure that my greatest common factor is negative. Between 24 and 40, I can take out a greatest common factor of 8, and they do not have x's in common, so I may not take out an x. Dividing by negative 8 leaves me with a positive 3x, and dividing by negative 8, my positive 40 becomes a negative 5. To the right, the greatest common factor between negative 12 and 30 is a negative 6. Remember, I'm taking out a negative because this first term is negative. Looking at my r's, I have 7 r's in my first term and 1 in my second, so I may take out 1 r. Dividing my negative 12r to the 7th by negative 6r, I'm left with a positive 2 and r to the 6th power. Dividing 30 by negative 6, I get negative 5, and I took out the only r that was a part of that term, so I have no r's left. Down to the left, I'm going to identify the greatest common factor of all 3 of these terms. Looking at 18, 12, and 15, I see my greatest common factor is a 3, and since the leading coefficient, negative 18, is negative, I must take out a negative as well. Looking at my x's, I've got 2, 3, and 2, so the most I'm able to take out are 2 x's. And for my y's, I've got 5, 3, and 4, so the most I'm able to take out is only 3. Dividing negative 18 by negative 3, I get positive 6. I took out all my x's and 3 of my 5 y's, so I have 2 left. Moving on to my positive 12, when I divide by negative 3, I get a negative 4. Taking out 2 of my 3 x's, I have 1 left. And I had 3 y's, but I took out all 3, so I have no more y's. Moving on to my positive 15, when I divide by negative 3, I have a negative 5. I had 2 x's, and I took out both of them. For my y's, I have 4, and I took out 3, leaving me with just 1 y. To the right, my greatest common factor of all 3 coefficients is positive 2. Since my 2 in front is positive, I do not need to take out a negative. Looking at my a's, I can take out 1a, and for my b's, I may take out b to the 3rd power. From my first term, dividing by 2 leaves me with 1. I had 4 a's, I took out 1, so that leaves me with a to the 3rd. I have 3 b's, and I took out all 3, so I have none left. Dividing 6 by 2, I get a negative 3. I have 1a, and I took out that 1a, so I have none left. For my b to the 5th, I took out 3, leaving me with b to the 2nd. And for my last term, dividing 2 by 2 leaves me with a positive 1. I have an a, I took out that a, leaving me with no more a's. I have b to the 3rd, I took out that b to the 3rd, leaving me with no more b's to the 3rds. So all I'm left with on the inside of my parentheses is 1a to the 3rd minus 3b squared plus 1. Go ahead and pause the video and try the next 4 on your own. For the first, you should have factored out 5x to the 3rd, leaving you with 5x minus 6 in parentheses. To the right, you should have factored out a negative 3a squared, leaving you with 9a squared minus 8 in parentheses. Down to the left, you should have factored a negative 2x squared y, leaving you with a positive 1 plus 2x plus 2y in parentheses. And last, you should have factored out a negative 2y, leaving you with 2y squared x to the 4th minus 2y to the 6th plus 3x in parentheses. We're going to go ahead and recall our process of factoring by grouping. Remember, our very first step is to look at the entire polynomial and see if there is a greatest common factor that we can factor out. So in this first, I have 2 and a visible 1 in front of this a. a -4 and a -2. There is not a greatest common factor, so I move to step 2. In step 2, I split my polynomial into 2 parts, and I look at the greatest common factor of the left and of the right. On the left, I see I can take out an a squared, leaving me with 2a plus 1. And on the right, I bring down this negative. I take out a -2. That leaves me with a positive 2a. And when I divide -2 by 2, I get a plus 1. Now notice these two parentheses match, so I can take those out to the front, 2a plus 1. And that leaves me with, in parentheses, an a squared minus 2 in my second parentheses. To the right, again, I'm going to look at the whole polynomial, all 4 terms, and they do not have anything in common. So I move to my second step, which is to look at my polynomial as 2 parts and take out the greatest common factor of the left, which is 3x squared. Factoring that out, my first term I'm left with just an x, and my second term, since I took everything out, I'm left with just a -1. From the right, there's an invisible 1 in front of my x. The only thing I can factor out is a -1, leaving me with a positive x. This positive 1 becomes a -1. Now when you notice, I have 2 sets of parentheses that are repeated, so I'm going to factor that x minus 1 out, and what I'm left with in my second set of parentheses is the 3x squared minus 1. Go ahead and pause the video, please, and try the next 4 on your own. From the first, you should have k plus 3 in your first parentheses and k squared plus 2 in the second. Next, you should have n minus 3 in the first with 3n squared plus 1 in the second. For this third on the bottom left, you should have m minus 2 in the first with 2m squared plus 3 in the second. And last, you should have p minus 3 in the first with p squared minus 2 in the second. Now keep in mind, if you did have your sets of parentheses switched, that's okay. For example, here in the first one that you did, you may have k squared plus 2 first with the k plus 3 second. As long as inside the parentheses doesn't change, that's okay. We're going to go ahead and continue our process of factoring each polynomial by grouping. However, first, we're going to have to factor out our greatest common factor. On the last slide, none of those examples had a greatest common factor. However, these ones will. So looking at 18, 12, 12, and 8, these all do have a greatest common factor of 2. So I'm going to factor that out, and I'm left with 9a to the third minus 6a to the second plus 6a minus 4. Now when you look at this remaining polynomial inside the parentheses, you should see that there is no other common factor. Now what I'm going to do is just leave that 2 on the outside and factor the inside polynomial just like we did on the last slide. So for a second, I'm going to go ahead and ignore the 2. I do know that my answer is going to end up looking like this with 2 sets of parentheses. So I'm just going to bring that 2 down and leave it on the front, just so that we don't have to worry about it as we go through this next process. So now that I've dealt with the 2, I'm looking just at the inside polynomial. I split it in half and find the greatest common factor of the left. That is a 3a squared. What is left is a 3a minus 2. And on the right, I bring down my plus, and my greatest common factor is a 2. So I factor out a positive 2, and I'm left with 3a minus 2. Now I can take out that 3a squared, so I'm going to factor it out. And what I'm left with is a 3a squared plus 2. So down here, I'm going to fill in my parentheses. I have that 2 on the outside with a 3a minus 2 in the first parentheses and a 3a squared plus 2 in the second parentheses. To the right, I see a greatest common factor of 3. So I'm going to factor out that GCF of 3. And I'm left with 6k to the third plus 4k squared plus 3k plus 2. Down here, I'm going to go ahead and set up my answer. I have a 3 on the outside, and then I'll be filling in these two sets of parentheses at the end. So now that I've dealt with that 3, I'm just going to focus on the inside of my parentheses and split this in half. On the left, I have a GCF of 2k squared. Factoring that out, I'm left with 3k plus 2. And on the right, I bring down my plus, and the only common factor they have is a 1, which leaves me with a 3k plus 2. So factoring out that 3k plus 2, my first set of parentheses is a 3k plus 2, which leaves me with the 2k squared plus 1 in my second parentheses. Go ahead and pause the video and try the next two on your own. For the first, you should have factored out a greatest common factor of 3. And factoring the remaining polynomial, you should have had 3b plus 2 in one parentheses with 3b squared plus 2 in the second. To the right, you should have factored out a GCF of 2, and the remaining polynomial should have factored into 3v minus 1 and 3v squared plus 2. Go ahead and again try these next four on your own after pausing the video. Okay, go ahead and check your work. Now the last thing I want to introduce to you is the process of factoring a trinomial by grouping. There's 4 steps we're going to follow. Step 1. Multiply the leading coefficient and the last term. Now remember, the leading coefficient is the very first number. In this case, my very first number is a 1. So I'm going to multiply 1 and 27. And what I get is a positive 27. Step 2. I am going to find two numbers that multiply to this number and add to the middle term. So this might remind you of your big X. So I'm going to create a big X. I want to multiply to the positive 27, and I want to add to the 12, so I'm going to put that on the bottom. Two numbers that multiply to 27 and add to 12 would be 9 and 3. So now that I've found my 9 and 3, my third step is to rewrite the middle term with these two numbers. So instead of a 12, I am going to split that up into 9 plus 3. So I'll have x squared plus, instead of 12x, I'm going to undo it and write it as 9x plus 3x plus 27. This is exactly the same thing as we started with, it just looks a little bit different. Step 4, we factor by grouping. So I split it into 2, find the greatest common factor of the left, which is an x. Factoring that out leaves me with x plus 9. And the greatest common factor of the right is a positive 3, which when I factor that out leaves me with x plus 9. Greatest common factor again is this x plus 9. So when I factor that out, in my second parentheses, I am left with my x and my plus 3. In order to factor by grouping, you must have 4 terms, which is why step 3 is so important. When we split up that middle term, we do get our 4 terms. For this second one down to the left, I multiply 80 and 1 to get 80. So I'm multiplying to 80 while adding to 18. My two numbers are 10 and 8. So I rewrite my 18 as 10v plus 8v plus 80. And from here, we factor by grouping. To the right, 15 times my coefficient of 1 is 15. So I multiply to 15 and add to 8. My two numbers are 5 and 3. So I rewrite my 8x as positive 5x plus 3x, and I factor by grouping. Go ahead and finish these last two on your own, and we will pick up here in our next lesson. Hope you enjoy the rest of your day.